Okay, guys, Chapter 10, Lesson 4, Solving Combined Inequalities. We're going to have more than one inequality put together, and we have to find the solution set for them, and we'll graph them. So look at these things right here. We have negative 2 is less than x, or if we read it backwards, x is greater than negative 2. And look at the graph. We have an open circle on the negative 2, and shaded to the right everything larger than negative 2. It doesn't include negative 2, so the circle's open, and x is greater than, so it's to the right. Now on this one we have x is less than 3. So let's look at the graph. We have open circle on the 3, and everything shaded to the left, everything less than 3. Okay, now, the two possibilities of combination. We have and or. You can put two of them together with and. You can put two of them together with or. So notice how and works. And means they both have to be true. So we need everything bigger than negative 2 and everything less than 3. So notice how they combine. It's like they come straight down, and it's everything in between negative 2 and 3. Nothing past this and nothing past this. D. What happens if you put an or? We need everything that's bigger than negative 2 or everything less than 3. Well, that just happens to be every single number in existence here on the real number line. So everything is shaded. The solution is everything. The sentence in example C is formed by joining the sentences in A and B by the word and. This kind of sentence is called a conjunction. To solve a conjunction of two open sentences in a given variable, you find the values of the variable that makes both the sentences true. Notice that the conjunction x is greater than negative 2 and x is less than 3 can be written this way. The graph of the conjunction consists of the points common to both the graph of negative 2 less than x and the graph of x is less than 3. Notice where the graphs in A and B overlap. So notice we did that. We saw that if we put this one and this one together, this is where they overlap. Okay. That's called a conjunction. Conjunction. In example D, the inequalities have been joined by the word or. That kind of sentence is called a disjunction. In order to solve a disjunction, you find the values of the variable for which at least one of them is true. One or the other, or both. As long as you've got one, you're good. The graph consists of all the points that are in the graph of A, the graph of B, or both of the graphs. So remember, the disjunction y is greater than 2 or y is equal to 2 is usually written y is greater than or equal to 2. Similarly with y is less than or equal to 2. That's an or sentence. That's a disjunction. Okay, so here's our first example. How would you draw the graph of t is less than 5 and t is greater than or equal to 5? Let's think it through. T is less than 5 and t is greater than or equal to 5. Okay, let's do it. So what we're going to do is draw our number line. 0, 2, 4, 5, 6. I'll go ahead and put them all in there. Negative 1, negative 2, negative 3, and it goes forever. T is less than 5. Open circle on the 5. I'm going to actually draw it like this. Draw it above it for a minute. So t is less than 5, and then t is greater than or equal to 5. Okay, where are they overlapping? Well, they overlap nowhere. There is no solution to this particular conjunction. Well, let's try the disjunction. What if I said t is less than 5 or t is greater than or equal to 5? Okay, so here we go. 0, 5. T is less than 5. There it is. So, and or t is greater than or equal to 5. Well, notice that our answer is is any of this or any of this, so it's everything. It's any real number. Okay. Now what happens if we want to solve something that's slightly more complicated? Let's look at that. Suppose I've got the conjunction negative 3 is less than or equal to x minus 2, which is less than 4. We've got to solve this and graph it. Remember, these are two different inequalities, so let's separate them. Negative 3 is less than or equal to x minus 2, and x minus 2 is less than 4. This is an and. So let's go ahead and solve and see what we come up with. Plus 2, plus 2. X is greater than or equal to negative 1, and plus 2, plus 2. X is less than 6. We solved both of them, so now let's get it on a graph. We need 0, a 1, negative 1, and a 6. Okay. Now, x is greater than or equal to negative 1. So I like to graph above it before I put my final answer on the line, just so I can see how they're going to act. So it's greater than or equal to, so it's solid, and it's bigger than that, so it's everything this way. That's my first part of the answer. Now it says x is less than 6. Closed, or open circle, and everything this way. So in an and, you're looking for the overlap. So notice, right there. So my final answer is going to be open circle there, closed circle there, and shaded between. Or you can write it like this. Negative 1 less than or equal to 6, x, which is less than 6. So there's the graph, and there's my answer. Okay, let's do another one. Let's do a disjunction this time. Okay, it says 2w minus 1 is less than 3, or 3w is greater than or equal to w plus 10. Okay, find the solution set and graph it. Let's solve for w in both parts. Divide by 2. W is less than 2, or minus w, 3w is greater than or equal to 10. 2w, divide by 2, or w is greater than or equal to 5. Okay, we need a 0, a 2, and a 5. Okay, so it says less than 2. I like to graph above until I see what's going on. Solid circle on the 5. Okay, so in an or, it's just everything included. No overlap needed. So there's our answer, and there's our answer. Okay, that's it, guys. Let me know if you have any questions, and get going. Thanks.